So Michael flashed up a whole series of RAD Lab architecture pictures. I want to now focus a little bit on the monitoring side of the story, which I was personally involved with starting from about fall of 2007. So I'm going to tell you about a bunch of tools. I'm going to tell you about Xtrace, which was our causal logging effort. I'm going to tell you about Ruckus, the instrumentation backplane. I'm going to tell you about dtrigger. I'm going to tell you about why you haven't seen either of those lately. I'm going to tell you about Chakra, which is our distributed log collection and MapReduce processing tool. And I'm going to tell you about the dashboard, which was now being shown, I believe, for its first and only time. So Wei mentioned logs. There's this problem with logs, which is I have a message in a file and I have another message in another file, and I don't know how they're related. And one approach to dealing with this is machine learning. Another approach is to use causal labels to stitch these together into a trace. And the idea is that you have annotations on your inter-process communication and on the flow within a process. And you can use this to sort of stitch together these event graphs. And this technique has been quite influential. People at Google are using it. It was instrumental to us in a bunch of debugging efforts. I stole this picture, by the way, from George Porter's dissertation. I guess he isn't here today, unfortunately. Dtrigger was sort of the flip side of that. The idea of dtrigger was there's all these machine learning algorithms we'd like to do. They're expensive. This was an effort devoted to developing techniques to sort of do very efficient, in terms of both CPU and communications, algorithms for things like PCA and support vector machines and so forth. You haven't heard, and so having seen that, we said, well, we need some sort of instrumentation backplane to tie everything together. The theory is that we would have this giant pub sub bus that would handle all the monitoring data and connect everything together. And we wound up calling it Ruckus because it was the backplane for the RAD Lab instrumentation and observation layer riot. It's gone away, and I'm going to tell you why. So the thing that we discovered when I went off to Yahoo and tried to deploy stuff there, and then as we kept building stuff at Berkeley, is that there are problems with this approach. Developers just hate external dependencies. And if you say, you should use my monitoring bus to move data around to do your internal control, they say no. You cannot introduce a dependency. It's absolutely unacceptable under any circumstances. No. And the result is that everybody who builds frameworks has to build their own communication channel because they just will not tolerate these dependencies. So given that everyone else has already had to build their own monitoring framework anyway, it doesn't make sense to build a grand unified one in the sky for which anyone can read anything at any point. The second thing is that we had this theory that communication was going to be really expensive, and so you need to do summarization early and to have sort of clever algorithms for getting locality on the processing. This turns out to be wrong because actually mostly people want to archive everything. And it turns out that if your monitoring is 4% of the network, it just isn't worth being too clever about the summaries. You just should save everything. And the last thing is that it doesn't make sense to build your own processing tools because MapReduce is a very large piece of engineering and you don't want to reduplicate that. So just reuse that. Also that real-time and batch are really different domains, and it's OK to just do a separate thing for each. So before I tell you about log collection, I want to tell you just a little bit more about the logging problems that we were focused on when we built our log collector. Supposing you have a whole bunch of email servers, and you want to know where messages are disappearing in your system. Rackspace, by the way, actually has a system very like Rackspace, I believe it is, has a system very like this for their managed email product. And the idea is that you collect logs from everywhere. You look for the sends. You look for the receives. If you find a send with no corresponding receive, that's where the message got dropped. And so you can pinpoint where the message was lost. There's a catch, which is that you need a reliable collector to make this work. This sort of approach, along with the sort of machine learning algorithms Wei developed, can be quite sensitive to lost messages, which means that you need to get the loss rate down as low as possible. And so we built a system called Chakra to handle these cases. For those of you who are seeing this for the first time, we got the name because in Hindu myth, Chakra is the turtle that holds up the elephant that holds up the world. The Hadoop logo is an elephant. It holds up people's worlds, so it seemed apt. So we had three basic premises behind the design. The first one was reliability matters. I think I already said why. The second is it just has to support MapReduce. That's the only processing framework that people really care about at scale. This may be changing thanks to things like Spark, but our premise was, must handle MapReduce. And the last is that it has to, in fact, handle Hadoop MapReduce because that's the one we have. So everything has to be built around those three core constraints. So we went off and we built a log collector. It's open source. It's available. People use it. There's a whole bunch of companies that use it. Selective Media and Tint are web advertising and analytics companies. CBS Interactive is the sort of web properties owned by CBS. Netflix, it turns out, uses it. We've gotten nibbles from Cisco. There may be other users who aren't sort of contributing back and aren't talking to us. So it's real. It has users. Each of these sites, I think, is order dozens of machines and order gigabytes to terabytes a day. So it's respectable data volumes. And we're getting code back. So as academic open source efforts go, I think it's been pretty substantial success. And it had influence on sort of other people's sort of second designs down the line. Right? So we really did learn something and contribute something here. The basic approach I think I've mentioned at retreats, but just for those of you otherwise, the idea is you have a whole bunch of data sources. You have an agent process on every machine that can get as close to the data as possible so you can do sort of highly site-specific things about log rotation policies and so forth. That it turns out that keeping the processing framework and the data at arm's length doesn't work because there's sort of quirks about when the data is readable and how you want it buffered and so forth. So you just have to get close to it. And then you can ship it across the network to a collector that dumps it into a file system. You dump it. The model was dump it into files as fast as possible to make it reliable, and then fix it up later with MapReduce to sort of deduplicate it and to make sure that it's in a read-friendly format. And you can also dump stuff into a SQL database or HBase for visualization. This wasn't designed to handle every data collection problem in the world. There's a specific domain in which it makes sense. If you don't have much data and don't have many hosts, you can use NFS. If you need more than that, you need Chakra. If you have a very high data rate per host, you actually don't need Chakra because then your data is a good match for the file system and you can just dump it directly. And if you have a really large number of clients without a huge amount of data per, you need some sort of clever aggregation or batching. And of course, at some point, you just need a better file system because there's a limit to the write bandwidth of what we have today. So we're handling the cases in the middle. Just to sort of clarify, there's existing systems that do metrics. We're not trying to duplicate that. We're handling logs. Metrics are orderly. They have simple structure right into time series. You can summarize them, and usually dropping a few data points is OK. Logs, as we said, you can't drop anything, and we don't know how to summarize them in general. So collect everything and collect it reliably. Just move the bytes. And then have sort of a processing framework tuned to it. This, of course, raises a question we've been dancing around for the last couple of talks, which is what to log. We actually did some thinking and some work on that. What we came up with is as follows. Suppose you have a log message like this. One way to look at this message is that the message is relating two different kinds of identifiers. It's relating task IDs to host names. And so you could just draw a graph where you have a node for each task ID and a node for each host name. Formally, you just define you have a node for each and an edge if the one includes the other. You can add more information to reflect that some identifiers are more common, some messages are more common, some messages are, even if the message appears many times, it only reflects a few identifiers. And so you can wind up drawing pictures like this to sort of express what's core and what's not core in your logs. And this was actually used and helpful in improving logs in Chakra and I believe also scats. And this work was presented at SLAML 2010. It happens that Chakra, as I said, was tuned for logs. We need to show you some graphs today. Chakra is not the right tool. We actually do need graphs. And Chakra is the wrong tool. So here is the architecture that we actually are going to use to draw graphs for you today. We have a whole bunch of servers. They dump stuff into a database. And then there's an R script that runs around every minute and draws graphs. It's simple, and it works. I want to just give you the quick tour of what these graphs are. But let me actually first start the dashboard. I'm told that if I click this, where'd that window go? How do am I supposed to drag this onto something? What do I do? It's appearing on my screen. To the left. Very good. All right. So graphs are now going to be rendering there. Is this the right way to do it? Good. All right. So what are we showing here? Well, we're going to show you the rain request latency once rain starts after the next talk. We're going to show you the request rate, the server count, and the CPU load for each of the web apps. We're going to show you the request rate and the server count now diving deeper into the storage layer. We're going to show you for Pickle not only the request rate, but also the latency percentiles. It doesn't make sense to do latency percentiles separately for SCADs and for pickle because each pickle query just maps directly into SCADs. So we're showing you it higher up at the pickle layer to give you a sort of end-to-end sense. And for Mesos, we're giving you the memory and CPU allocations for each of the frameworks. All right, questions? Yeah. For the dashboard? Less than a minute, mostly because we have one feeble, underpowered Amazon Elastic SQL storage instance running in the data center. Right? We knew how big the demo was going to scale, so we sized it as tightly as we could. A couple hundred? The questions for just for the recording were, what is the sort of latency like on the dashboard? And the answer is it's about a minute because we designed that we sized the database to get that latency, and it was not worth paying more money to get it below that, we thought. It's just a cost trade-off. Yeah?
So there is a commercial system called Splunk that you might be familiar with, and I was wondering if you attempted to compare Chakra to Splunk at all?
They're doing somewhat orthogonal things. Splunk is a framework for, given your logs, doing deep analytics on it. Chakra is a framework for collecting your logs in the first place. Right? And the Splunk guys, I believe, Archana, I know, works there. I don't know if she can comment on this. They built their own MapReduce framework to do their processing, which was a lot more ambitious engineering than we thought we could or should do. They decided to use, I believe, syslog to move logs and tolerate the losses. We thought that reliability was a higher priority, so we designed for reliability. I think those are the sort of big differences in where we are in the space. Did that answer the question? I mean, you could do Splunk-like things on top of Chakra. Chakra is designed to be the sort of infrastructure for collecting and storing the data, not the analytics tool on top.
Splunk will take data using, syslog is just one. It'll take data over the network. It'll eat files. I mean, that's one part of it. The other part is what you mentioned is the analytics on top of it.
Yeah.
And that actually came a little bit later in Splunk's history. In the beginning, it was mainly geared towards the collection and just, needle in haystack finding a specific log entry type of thing.
Okay, so I think we're running a little bit behind schedule, so we're going to cut it right now and let Rian give his talk. But Ari will be available at lunch if you have more questions about our monitoring and analytics story.